what if? But what if, you know, demand had been different and I had ordered differently, okay? So it's a very small example, but it introduces all of the main ideas of what you do when you're modeling, okay? Then we went into this one, this machine purchase decision, and didn't get very far into it at all. But if you remember, all of these numbers are on the spreadsheet, so we don't have to look back through all these numbers, they're all gonna be on the spreadsheet. We had a couple of things that we had to fill in before we could even start this, but this is where we're gonna start. Okay, we filled in a couple numbers, we'll talk about what those were. Now we're gonna move to doing the cash flow, and the reason that we do the cash flow is so that we can make an apples to apples comparison between these machines, where we can use performance measures like net present value or internal rate of return or payback, or something where we can say, you know, that this, we choose this option over this option, and here's why, because we actually analyzed it with, you know, different financial measures. So that's what we'll be doing right there. We've got to get to. So here was the model. Oh, it's kind of tiny, but when we got into the model, the only things that we did, okay, we needed to be able to fill in price. We didn't have price filled in when we opened it up, and the reason we didn't have price filled in is because price is dependent on how many you order. There's a pricing structure that quantity discounts, okay? So we had to know how many machines we needed. So the first thing that we had to calculate were these two numbers right here. We took demand and divided it by the capacity of that machine to figure out how many machines we needed. Now the interesting thing about that is if it came up with a fractional number, which it did originally, 8.333, okay, if it came up with a fractional number, then we had to round up because we had made a decision and an assumption that's in this model that we want to be able to produce that 10,000, not just produce what we can with the closest number of machines, you know, we want to be able to produce the 10,000. What we believe demand is going to be is what we're going to produce, which is what we're going to sell. That's going to be an assumption in this model. Okay. So we had to round up. So we did that. We used those numbers in VLOOKUPs to get the price. And that's all we did, and we stopped there. Okay. Because the next step is to fill in the cash flow, because the cash flow is necessary in order to do the NPV and the IRR. I mean, you have to have the cash each year listed out. And so the first thing we want to do is put in the time zero, in this case, year zero cash flow. Because before you ever get started on the production of these items and making money off of them, there was something that you had to do first. And this is very often the case that in time zero, whatever, year zero, quarter zero, whatever it is, time zero, that you have some initial outflow of cash, okay? In our case, the initial outflow of cash is doing what?
Buying the machines.
Buying the machines. Buying the machines. So we have $700 per machine. We're buying 9 machines. Okay. So B4 times B15. The thing about the B4 times B15 is that here in this cash flow, I need for that to show up as a cash outflow. Okay, so I need for it to be a negative number, so I'm going to put a negative sign in here somewhere. Doesn't matter where. Not either one of them. We'll make it negative. So I do want that to show up as a negative number, because when I am doing the functions that pull these ranges in, okay, when I'm doing IRR, okay, it pulls this range in, I need for that to appear as a negative number. Actually, payback needs it too. Okay. Since this one was, you know, right there lined up in that column, I just copy it, don't need any absolute addresses. This one, I'm buying 11 machines at $300 a piece, so the initial cash outflow is not as great with machine 2 as it is with machine 1. All right, so that's fine for time zero, because that's my initial outlay of cash. Then I start moving into time period 1. During time period 1, I am now manufacturing these things, and annually I'm selling 10,000 of them with a 40-cent margin, but I've got other expenses involved. So the first thing I want to put in here is just what the formula itself would be for the net cash flow, okay? I'm going to take cash inflow minus cash outflow. And my cash inflow is what?
Unit profit, no,
The unit profit margin.
times product demand.
Yes. So in a year, I assume that I get this, 10,000 units, 40-cent profit margin on each one of those units. This is a simplistic model. That's the only, inflow of cash that's shown on here. But then there is actually only one outflow of cash. And what's that outflow?
Annual maintenance.
The annual maintenance. So I have an annual maintenance on this one, $330, and that's per machine. I have 9 machines. So this is my cash inflow, 10,000 times 40 cents. This is my cash outflow, 330 times 9. So cash inflow minus cash outflow gives me the net cash flow. And that's what it's gonna be every year because we didn't put any kind of increase or decrease from year to year. But there is one interesting thing about this, even before I start copying it. If the useful life of the machine in this case is 10 years, and I have this going 10 years down. The useful life of this one is only 7, but if any of that ever changed, I would need to make sure that that calculation of net cash flow only shows up if I'm still within the useful life of the machine. Because if I'm not, then this should be 0, this is done. So around that little calculation, I'm gonna do if, I don't need another equal sign, if, and check to see if the year that I am in is less than or equal to the useful life. So in other words, check to see if A19 is less than or equal to B6. Am I still within the useful life of the machine? Because if I am, then that calculation will be made. Otherwise, go over to the end, comma, then it should be 0. So I checked the formula first, and then I embedded it into an if statement. That's checking to make sure I'm still within the useful life of the machine, because if I'm not, then I would just want that to display as 0. Here's the thing about this formula though. I want to copy this down, I want to copy it over, I don't want to type this in a bazillion times. For the A19, I'm going to want the rows to change, but not the column when I move it, and so I'll need a $sign in front of the A. And then for every reference up here to a cell in column B, I want the B to change to C when I move it over, but I would not want the rows to shift down, okay? So in every single one of these B references, I need a $sign in front of the row. Well, where'd I go? There we go. Every single one of them. So the A19 has to have it in front of the A, but all the B references have to have it in front of the row number. Now, that's actually not going to change the number I have in here right now, but it does set me up to be able to copy this down, then copy it across, and because it's nested in that if statement, my machine 2, which only has a 7-year life, doesn't display a cash flow. I mean, well, it does, it's 0, but it doesn't, it's done, so the cash flow is 0.
Did you write this formula in B19 or B20?
I put it into B19.
Okay.
B19. And then I copied it down and I copied it across. Yeah.
So basically, the end of the year has to be less than or equal to the machine useful lifetime. So
Yes.
it has to be below that, because if it's above that, that means the machine won't work anymore.
We're done.
Yeah.
Yeah, we're done. We retired the machine, we stopped the project. This particular project is one that we would just discontinue after 7 years.
Okay.
Yeah. I know, you can complicate this model a whole lot more. I mean, you can make it where you, at that point, purchase more machines, and we can roll this out on a larger time horizon. But this is just a real simple example to get at some of these financial functions and making these comparisons between these options. Okay. Everybody's good with the cash flow? Your cash flow looks good? Our reason behind laying out the cash flow in our spreadsheet year by year by year by year, starting with year 0, is so that we can do these financial measures and compare. Because otherwise, we're just looking at this and, you know, how do we choose to compare? How do we know which machine to purchase? Well, we really ought to have something that's relatively objective and comparing them on the same basis. The 3 measures we're gonna use for comparison are gonna be NPV, IRR, and payback year. So, for business students, we recognize that there's a time value to money, right? So we know that if I gave you $1,000 today, it's worth more than if I gave you $1,000 a year from now. Why? Because opportunity cost, things you could be doing. So we understand this time value. Well, NPV takes time value into account. So when we're looking at this and saying, this is our cash flow over the next 10 years, and starting in year 0 with our outflow of initial investment, and then that's our cash flow, it's gonna take the net present value of each of these things, but it's gotta pull it back to today's dollars, all of it back to today's dollars. So if we were looking at 2 possible things here, Project A and Project B, okay, that we could be undertaking, and over the next 5 years, they made 100, 200, 300, 400, 500, or 5, 4, 3, 2, 100, okay? We would choose which one?
B.
Yeah, we'd choose B because, why would we choose B?
We have more.
Yeah, we get more of our money faster. This one's just as straightforward laid out as it possibly could be. If our numbers kind of bounce around, and we would actually need to make a calculation to be able to figure this out. Because here's what happens. When you're looking, what you want to compare from one project to the other is not, if you just added that all up, they would be the same, okay? But we want to compare their net present value. What is it to us today? Well, here's what happens. This one in time period 1 has to be discounted back at whatever rate you choose. It has to be discounted back 1 time period. This one, discounted back 2 time periods. This one discounted back 3 time periods. This one 4. This one 5. Add that up. That's NPV. Okay, that's your net present value. Well, what have you done here? You've discounted back $500 back only 1 time period. What have you done here? You've discounted it back 5 time periods. So even though if you just added them without taking into account time value of money, they would be the same, it would be the same number, okay? It's very different when you start taking into account, you know, time value of money. So NPV is a great measure because it's telling you, you know, comparing them right now, what's the net present value? That's what we're gonna do with this cash flow. That's what these cash flows are. We're gonna discount this back 1, 2, 3, okay. So, we're not. Excel's going to do that. But here's how the NPV works in Excel. The function name is NPV, so that's nice and easy. And the first thing that it wants to tell you, wants you to tell it, is the rate. Now, this isn't a rate like I'm throwing this in a, you know, CD and making 0.0 something. You know, it's not a rate like that kind of rate. It's a rate of, it's often referred to as a hurdle rate. It's kind of an expectation rate for you investing your money into something. You know, what's the normal rate that your company expects? You might get this from your management. It just might be a sort of industry-wide. You know, there's just an expectation that when you invest in something that you're going to get some sort of return. So somebody's going to give you that hurdle rate, okay? Well, we've got a hurdle rate or rate of 15%. So I'm going to reference that cell. And then I go on to put in all of the values that I'm wanting to discount back. I don't have to do them individually because they're in a range. But here's the thing about NPV. The NPV, Excel NPV function, okay? You've got to start this range with time 1, not with time 0. Okay? You've got to start it with time 1 through n, however many you have. So the question might be, does that initial investment not matter when you're calculating NPV? No, it matters very much. It matters a lot. It has to be included in your net present value calculation, but is not in the NPV Excel function, okay? So where you have to now take that is you have to take this and reduce it by that initial investment. Ours is up there as a negative number, so I'm gonna say plus this. So, because it's already up there as a negative number. And so in the entire calculation of net present value for this particular, cash flow, I do need it, but it's outside of the function itself. And if you put it in there, you're gonna be just off, because that's not what NPV is expecting. NPV would discount this back one, this one two, this one three, this one four, because, whatever it came to first, it would discount back one period. That's why it doesn't go, that's why this doesn't go inside here, because it would actually skew your results. Okay, so this, I'm gonna copy this over, because everything that's there, I just copy it it's relative to the next column, so we can talk about both numbers at once. Okay. So that's actually negative 1130.67, whereas this one's positive 2358. I think we probably realize we'd want to go with the thing that's positive, but there's a better question than that. That negative number, that negative 1130.67, is that telling you that this project loses money?
Yes.
Is it? It's not actually telling you that. It's actually not telling you that this loses money. What is it telling you?
What you have.
Exactly.
The internal, like the rate you'll get your return on investment, like the.
You're on the right track. Okay, here's what it's telling you. It's telling you that this project doesn't meet your 15% hurdle expectation. It doesn't. It's not saying it loses money. It's not saying it has a negative internal rate of return. It's just saying it doesn't meet your 15% goal that you're trying to at least get to. Because if our goal hadn't been 15%, what if our goal had been 8%? I'm gonna throw an 8% up there. We'd have had a positive NPV. So this wasn't saying we were losing money because it was negative. It was saying we weren't reaching our 15% hurdle rate, our expectation rate of 15%. We weren't reaching that. Doesn't mean it loses money. This one exceeds our 15%. That's why it's a positive number. Obviously, that's better, okay? With respect to this measure, it's better. If you had two positive numbers, the higher one would be better. Okay. But the kind of follow-on to this, then, is to come up with what is the internal rate of return. Okay, what is that rate? So, what internal rate of return is, it's the rate at which NPV would be equal to 0. Okay? So the rate at which NPV would be equal to 0, that's the internal rate of return. The function's super easy, IRR. There you go, IRR. Internal rate of return. And this time it's different how you put it in there. You do put the entire range of time 0 to time n. And don't worry about this little optional thing that says a guess. You don't need to put a guess in there. You don't need to put a seed value in there to start it out. The computation of this machine is no problem coming up with it without you giving it a starting point, okay? So you put in IRR, you put the entire range, and in fact, IRR does not calculate if you don't have both positive and negative cash flow. And a lot of times your only negative cash flow is your time 0 initial investment. Not always. Sometimes things lose money the first year or two and then they pick up. But certainly you have to have some negative, and your initial investment times 0 is usually at least one negative you're gonna have. But for internal rate of return to actually calculate it, has to have both positive and negative cash flow. All right, so here's what the rate actually is. Let me give it some decimal places. Okay. And this one's internal rate of return, just copy it over. It's a lot better. 36.558. We knew this was something higher than 15%. We knew this was something less than 15%, because this came up with a negative NPV, this came with a positive NPV. And if you want to see for sure what I'm saying, go up to the discount rate and put in 10.107. It has lots more decimal places. If I put more decimal places in, I'd get this down to a 0, you know, if I put more decimal, but you see that's the rate at which your NPV would be equal to 0. So here's our thing, you set a hurdle rate for a reason, because that's an expectation that you don't want to invest in projects that don't at least make that much. And unless you get an NPV of 0 or higher, you know, you haven't reached that. You haven't reached that expectation rate. And in fact, what was the rate that we reached? Well, 10.1%. Okay. Everybody good with NPV and IRR? They're pretty straightforward. You gotta get the calculations in there correctly first for the cash flow. Once you do, then it's easy to calculate these two things. And so far, which would make sense, that we would choose machine 2 right now, based off of both net present value and internal rate of return. There is one other measure, though, that we could do if we wanted to. Well, there's lots more measures we could do if we wanted to. There's one more we're gonna do, and that's the payback time period. And it does not take into account the time value of money. Okay, so it's not taking that into account. It is just a measure that tries to figure out at what point do you recoup all of your initial investment, but not time valuing your money, okay? Just when do you recoup your initial investment? So here's what you do. Over here, this is gonna be machine 1, machine 2. Over here, you put in for time 0, where are you at the end of time 0, money-wise? Well, at the end of time 0, I'm just referencing cell B18, I'm $6,300 in the hole, right? Because I spent $6,300 and bought these machines, but have yet to begin the production. You know, so at the end of time 0, I'm $6,300 in the hole. Year 1, I start producing. My assumption is I sell 10,000 of them, 40%, you know, all that stuff, and I make $1,030. It's probably scaled, but anyway, make $1,030. So where am I now? Well, I started the year $6,300 in the hole, E18. And then I add to that anything I made, which was in B19. So E18 plus B19. And I'm coming out of the hole. You know, I'm up a little bit. And if that, now that formula can be repeated the rest of the way down. And what you see is that you're coming out of you're paying off, you know, that $6,300, $1,030 at a time, until you eventually get to a year where you have a positive, a positive value. It was during that year 7, that you finally recouped your initial investment. And these are set up in such a way that I can just copy this whole column over one. Started out $3,300 in the hole, make $1,360, I get out way faster, okay? I've reached positive in the 3rd year. So year 3 is my payback year. Didn't take into account the time value of money. Didn't take that into account. But again, you can contrive examples, I've seen them, where the different measures actually would point to different things. This particular one, everything points to machine 2. It's got a better NPV, it's got a better IRR, it has a shorter payback period. Everything points to machine 2. So we would just jump on in there and say, let's buy machine 2. Except that when we are modeling things, we always want to, after the fact, say, but what if? What if something is different? Because here's the thing about doing what if analysis. If you do a model and reach a conclusion that this is what you should do, okay, for your own peace of mind, you know, you go back and you alter some of the input variables. And if you alter a few input variables here and here, because if you remember, they're built on some predictions, some assumptions, things like that. So you go alter some of those input variables. If you still would reach the same conclusion, even when you kind of do a little variation of some of those numbers, like, well, what if this isn't it, what if this isn't it, but you still reach the same conclusion, you feel a whole lot better about the conclusion that you've reached. You just do, because even when you made minor modifications to the input, you still resulted in the same, the same decision in this case. Okay. But what if you put in some minor changes to your input, and it changes the decision that you would make? You don't feel quite as good. I mean, it makes you a little nervous, because you know that you built the model based on some assumptions and predictions and things. And so now you're a little more nervous because you're thinking, what if some of those things do happen? And now I've, made the wrong decision. This isn't what we should do. We'll lose money, not in this example, but that means that your output is very, very sensitive to changes in your input. Okay? And when it is, there's no good way around that. Sometimes you have to deal with that kind of level of uncertainty, but you certainly aren't as comfortable or confident about the decisions that you make. So you never really just stop a model and say, done, I'm done. It is a good idea to look at things that you think might be some uncertainties. So I have put together an area, and it's not already on here, so I'll just tell you how to real quickly do this. I've put together an area where we're gonna do a data table for what if analysis. And what we're gonna look at is, what if we're off on demand? What if demand is not 10,000 units? Because demand is one of those things that you might have wrong. You might predict and it's not the way you want. So over here in, where am I? In an 03, I just copied these headings, machine 1, machine 2, and just pasted them over here. But what I did to set up the one-way table, I started this in M5. You can kind of start wherever you want, but I started in M5. I put in 1,000, go to the next cell, put in 2,000, drag it down to 30,000. In other words, get the input in there that takes your demand all the way from 1,000 units, way lower, to 30,000 units, way higher. Just do a huge span of demand numbers. Maybe it's a brand new product and you really don't know what your demand is gonna be. So just do a huge demand range going from 1,000 to 30,000 in steps of 1,000. So that's gonna be our varying input. It's gonna be a one-way table, that's gonna be our varying input. What I wanna see, well, there's a lot of things I could see, but I'm gonna go ahead and just look at NPV for each machine. So I'm gonna reference right under where it says machine 1, but above the row where it says 1,000. I'm gonna reference B30. I'm gonna reference B30, I'll copy that, and basically here now it's referencing C30. Obviously, I could have done this where I was covering stuff up with custom number formats, but anyway. I'm referencing at the top of the column B30, top of this column C30, because what I want to see for the varying levels of demand, I want to see what would the two different NPVs have been under those varying levels of demand, right? Does everybody have the setup ready? Then the one-way table, I'm capturing that row that has the output references, all the way down to 30,000. That's my data table. I'm gonna have two output columns, one input. So I go to data, what if analysis, data table. My data tables, my one-ways are always gonna be vertical. They just are. That's just more conventional. So my input is found in a column. So I go to column input cell, and where should that 1,000, 2,000, 3,000 be plugged in? Right there. Okay, so now I'm gonna point out something. Remember when I said you didn't want to just go over here and type 10,000 in, and the model was already done for you, but that number referenced this one. If that number didn't reference this one, then this one wouldn't change when this one changes. So there are a lot of reasons why you never want to take one hard-coded value and put it in a second time, okay? You always want to reference it to the next location. Well, anyway, so I just point that out again. So that's where it should go, B11, column input cell will be B11. I click OK. I don't like the format. Gonna fix the formatting a little bit, but there are my NPV values starting all the way at a really low demand of 1,000, which would have you choosing machine one, machine 2, machine 1, machine 2, machine 1, 2, 2, 2, 2 for a while, 2, oh, 1, 1, okay. So that's interesting, but kind of hard to read. You don't have to do this part if you don't want to, but I'm gonna set up a little if statement to make it a little bit easier for me to decipher when I'm looking at it. And I'm gonna check to see if the NPV for machine 1 is greater than the NPV for machine 2. Just on that one row. Because if it is, then I do wanna type text, and you have to put text in quotation marks. I wanna type the text machine 1. If it's not, then I wanna type the text machine 2. So that gives me a little better visual of this, so I don't have to do the numbers really fast in my head. Okay, machine 1, 1, 2, 2, 2, 1, 2, 2, 2, 2, 2, 1, 1, 2, 1, 1. Okay, I can even get a better visual. Again, you don't have to do this because this is just for me, so we can be looking at it. But I'm going to put a conditional format on those cells and highlight those cells if they equal machine 1. I'm actually gonna make them like, and I'm doing this quickly because again, you don't have to be doing this part right now. I'm gonna make them yellow, that was the heading I used. Then I'm gonna turn around and put a second conditional format on those same cells where I highlight them if they equal machine 2. Gotta spell it right. And this time I'm gonna make them that sort of turquoisey weird blue. Okay. You don't have to do this conditional format if you don't wanna do it right now. I just want us to, well, I'm gonna get it where we don't see the actual numbers aren't an important thing right now. I just kinda wanna look at this. I actually wanna see more, oh no, that's good, it's got it in there. Okay. It seems kind of odd, but let's go back to where we were. Yes?
For the data, after we press enter on the table, what format did you do for the numbers?
Oh, I did the real quick, whatever the dollar sign was on the menu. I just did it really fast.
Oh, like counties or?
Is that accounting? I just don't know the names of them. Whatever this one is right here.
Oh.
Yeah, it's accounting.
Color.
Yeah, I did that one really fast. So, we were thinking demand would be 10,000. That's right here. Did I have something wrong? Cause that was different, all the numbers look right. Okay. Maybe I had it wrong in the last class. It's hard to say. When I'm at 10,000 and I chose machine 2, which was true, I did. If I'm off just a little bit, does that change my decision? Well, it depends on which way I'm off. Are you getting these same highlighting things? Okay. It doesn't, I'll go back and look at it later. But if I'm off just a little bit, would it change my decision? Well, yeah, in some cases it would, depending on what you were originally forecasting that demand would be. You might be right on the edge. Now, if this was a little bit more linear type problem, you would end up with typically something that's more like, well, if it's below this amount, you'd use this. If something's below this amount, you'd use that. If it was a little bit more linear. This one's not so much so. It's not a linear problem, and it's got a real lumpiness to it because of the nature of the way the problem is set up. So there are a couple of things, a few things that kind of factor into this, having this machine 1, machine 2, machine 1, you know, this back and forth thing. What can you see about this problem that makes it a little, what we refer to as lumpier? What do you see about this problem that makes it like that, as opposed to being nice and linear? Any thoughts? about what you're changing in the input. Over here in this input, you're changing demand. Okay, so now think about that, because that's what's making it change, you know, what machine you would choose. Any thoughts? Our demand dictated how many machines we needed, right? Because we took demand and we divided it by the capacity of that machine, and that told us how many machines we needed. But we didn't just say we needed 8.333 machines. We said we needed 9 machines. We rounded up. So, and that's because we were going to meet our demand. That's, what if when we divided it, it was 9.9 and we rounded to 10? There's a whole lot less excess capacity in that situation than there is in this situation where we have a lot of excess capacity. We didn't really need 9 machines. We only needed 8 1/3 machines, but we had to buy 9 machines. So at all these different demand levels, we will sometimes be more fully utilizing our machines and sometimes less fully utilizing our machines. And it doesn't happen at the same place for machine 1 and machine 2 because these numbers are different, okay? And now take it a step further, the number of machines that we needed told us what the price was gonna be. Okay, so now that's telling us what the price is gonna be. And if we had just a little more demand, needed a few more machines, it could bump our machine price from 700 to 400, or, you know, from 650 to 400. You know, there could be a real jump, a reduction in price by just needing a little bit more, or a bump in price by needing a few less machines. And that doesn't happen at the same place either. Not that it ever was going to because of the whole machine thing, capacity thing, but you've got, you know, you've got these things going on that are causing this to be a lumpier kind of situation, not a nice, clean, linear sort of look to it. But that is kind of what it is. Some of these things allow us just to be able to see it a little bit better. At this point, when we're doing this model, we haven't gotten into solver, which we would need for our models, at least originally, to be linear for us. But it is a good representation of another model building process. I realize the shell was already here, but it let us use some financial functions and do some financial measures, and then kind of recognize the things that were going on in the model that made it have output like that, an outcome like that. Okay, questions about this time value problem? That would have been the end of the last day of class, Tuesday. And then today, we jumped over here